Okay, so looking at the sine and cosine graph. So we're looking at a function now that we feel really comfortable about our unit circle. Can I fill in this table? So what is sine of now 0? So what's sine of 0? 0, good deal. Sine of pi over 6 is going to be a what? 1/2. Sine of pi over 4 is going to be a root 2 over a 2, or a what? That 0.707, right, for graphing measures here. All right, so what about pi over 2? So what is sine of pi over 2? It's going to be a 1. What about sine of 3 pi over 4? Still a positive 0.707, right? So root 2 over a 2. Sine of 5 pi over a 6. We're going back down to a 1/2. And then what about sine of pi? That's a what? 0. Good deal. Okay, what do you notice right there from 0 to pi? What is happening from 0 to pi? It looks like a parabola, right? So I have a peak. Whoops. I have a peak at 1 there, and it looks like it's symmetric on either side. Yes? So the same things I'm going to have on both sides there. Yes? Okay, so what about filling in the rest? So what is sine of 7 pi over 6? So what's going to happen when you go, this is basically the third quadrant here, so 7 pi over 6. So that's going to be a what? Negative 1/2, good deal. What about sine of 5 pi over 4? So all these values are going to be what? Negative. Sine of 3 pi over 2 is a what? Negative 1. Sine of 7 pi over 4 is going to be a what? And then sine of 11 pi over 6 is back to a negative 1/2. And then let's go ahead and add a 2 pi in there. So what is sine of 2 pi? Back to a what? 0. All right, so what do you see about this part of the graph? Do you have some symmetry going on as well? So you have a what type of point here? So you have a, so you have a minimum point, so you got a valley, right? And then you've got kind of symmetry happening on either side of that valley. Okay, so let's plot these points here. So at 0, I am going to be at 0, okay? At pi over 6, so the reason I didn't put these on here, so pi over 6 is about where? Like right there maybe? Because they're not the same distance as the pi's over 4s, and pi over 3 would be over here somewhere, right? So that's kind of the reason why we don't kind of graph these. But pi over 6, let's just graph one of those. So the pi over 6 one is a what? 1/2? Okay, pi over 4 is that 0.707. Pi over 2 is at a 1. All right, let's think about this for a second. The one that we left off inside of here was a pi over 3. So what is sine of pi over 3? Okay, so root 3 over 2. If you put that in your calculator, the decimal, I think I did it in the last class, it was like 8.86 or something like that. So that kind of follows suit. It follows that line, right? It's not kind of, it's going to be a continuous curve, yeah? Okay, at 3 pi over 4, I'm back down here to that crazy root 2 over a 2. At pi, I'm going to be down to a 0. At 5 pi over 4, I'm going to be at 0.707. At 3 pi over 2, I'm going to be down here at a negative 1. At 7 pi, I'm going to be at a negative 0.707. And then at 2 pi, I'm going to be back at 0. Yes? Okay. So what do you see about this beautiful graph? It looks like a wave, right? A blue wave. Should have drawn it in blue, yes, to make a blue wave. Okay, so does it stop here? Is this all the graph that I see? Is it continuous? Why is it continuous?
Because the circle keeps going.
It keeps going, right? So it keeps going forever and ever and ever and ever and ever and ever and ever. Okay, so it can go like so. Okay, can it go in the opposite direction? So can I have negative values? I can, right? We just talked about those. So we can evaluate this in our negative. So it's going to look, basically, I'm going to just kind of repeat the curve over again. Okay, so it's going to continue in both directions. So it's never going to stop, but it's going to repeat itself, right? So after 2 pi, so after this 2 pi here, it's going to start repeating itself. So all this table value will repeat one more time. It'll repeat again, and it'll repeat again, and it'll repeat again, right? So nothing will change. It's just what these values will be. So if I asked you to plug in, what did we say? 9 pi over 4 inside there. So sine of 9 pi over 4 is what? It's this, right? So it's root 2 over 2. So it's a 1 rotation, right? Because we're subtracting and adding. Did I add right? 9 pi over 4, right? That's right. That would be, okay. All right, so it's going to keep repeating itself. So how long, so from 0 to this 2 pi, so how long does it take before it starts repeating itself? So we graphed part of it. So that, do what? 2 pi. So 2 pi before it starts repeating itself. So this is a periodic function. So sine and cosine are called periodic functions. So that means that it's going to keep repeating itself. So it's periodic. So it takes 2 pi. So 1 full length of a period is going to be 2 pi. So we did talk about this a little bit in foundations. We gave you one of the parent functions here. So was sine, but we didn't ask you to graph it. We asked you to just kind of look at it. So what do we notice? What's another thing that we notice about sine now? So it repeats itself every 2 pi. Okay, or negative 2 pi, right? So it's called a period, it's called 2 pi. If we start to transform it a little bit, it'll look a little bit different than that. But right now, 1 period of sine is 2 pi, okay? So 1 rotation of the unit circle. All right, what else do we notice about the range, the peaks and the valleys here? So what's the range of my function? So 1 to negative 1. So remember we write it as the smallest. So negative 1 to what? 1. So we'll go from negative 1 values to positive. Or what about the domain? Do I have any restrictions on sine? I don't. So it's all what? All real numbers. So all real numbers. So negative infinity to infinity. All right. What about the y-intercept here? The y-intercept for sine is what? 0. Okay. But what about the x-intercepts? So x-intercepts are going to repeat every what? Every pi, yes. Okay. So every pi, I'm going to have an x-intercept. Okay. So we could say what, n pi? Where n's are our integers. So remember when we kind of talked about that a little bit? Okay, so far so good. So that's sine. All right, so what's going to be a little bit different about cosine when you fill out the table? So what is cosine of 0? So instead of starting out at 0, 0, it's going to start out at 0, 1. So my y-intercept here is going to be a 0, 1. All right. What about cosine of pi over 4? Square root of 2 over 2, so that's going to be what, 0.707. Cosine of pi over 3. So pi over 3, so it's going to decrease, so it's going to be a 1/2. So if I would have asked for pi over 6, that would have been right there, right? So cosine of pi over 6 would have been that root 3 over 2, right? Okay. All right, so what about cosine of pi over 2? So cosine of pi over 2 is what? Zero. Good deal. Okay, and cosine of 2 pi over 3. Good. A negative 1/2. Okay. Cosine of 3 pi over 4 is a what? Square root of 2 over 2, negative, right? What about cosine of pi? Negative 1. Okay. So I don't see right now any like pattern like I did with sine. Okay. So all those are different values so far. All right. What about 5 pi over 4? So cosine of 5 pi over 4. Okay. Root 2 over 2, so negative root 2 over 2. Cosine of 4 pi over 3 is a negative 1/2. Cosine of 3 pi over 2 is a what? 0. All right, so I kind of am seeing a pattern. So after pi, what's happening? It's going to repeat a little bit, right? Okay, so 5 pi over 3. So cosine of 5 pi over 3 is going to be a what? Positive 1/2. Cosine of 7 pi over 4 is going to be a 0.707. And then 2 pi, it's not on here, but 2 pi then will give me back to what? 1. All right, so if you look at this table value, you see that at pi, that's going to be my minimum value. And then I start repeating myself. Okay, so I start going back kind of up. Okay, all right, so let's label my axis here. So at 0, I'm going to be at 1. At pi over 4, I'm going to be at that 0.707. At pi over 2, I'm going to be at 0. 3 pi over 4, I'm going to be at a negative 0.707. At pi, I'm going to be down here at a negative 1. 5 pi over 4, positive 7.707. Nope, sorry, not positive. Negative 0.707. At 3 pi over 2, I'm going to be back at 0. At 7 pi over 4 is a positive 0.707. And then back to 2 pi. So let's look at this graph. So if I were to try to connect the dots here a little bit, this one's a little harder to see. Okay, but what's going to happen after 2 pi? So what's going to happen after this 2 pi? I'm going to take this function and I'm just going to move it over, right? So it's going to look like this, over and over and over and over and over and over, right? Okay, so let's see if I can, I think it goes right there. So it'll go like that, over again. And we could keep doing it. Okay, so what about cosine? Cosine is also a what type of function? Periodic function. So cosine of theta is also periodic. Even though it starts out at different values, what is one full period of cosine? So how long does it take before it starts repeating itself? 2 pi, perfecto. Okay. All right, what about the range here? So what about the range of values? Same thing, right? So it's going to go from -1 to a 1. What about the domain? All real numbers, right? So -infinity to a positive infinity. All right, what about the y-intercept here for this one though? The y-intercept, so it passes through the y-axis at what? Y. Y-axis, sorry, y-axis right there. So remember, this is my y-axis, this is my x-axis. It's okay. So it's kind of weird because we're taking a unit circle now and we're like taking it, instead of looking at it in terms of an axis like we were and making a circle with a radius, so now we're stretching it, right? So we're taking that unit circle and stretching it out on a different x and y axis. So that's kind of gets a little confusing. So y-intercept is going to be at 0, 1. And then what about the x-intercept? So now you can tell me. These are all pi's over 2, right? So it's going to be a multiple of my pi over 2. Okay. So every pi, right? So it's going to be at n pi over 2. Plus pi, right? Because it's not at 2 pi over 2. So where n is odd, I guess you could say. Or you could just add pi to it. Is that how you would write that? N pi over 2 plus pi over 2, or n pi? Because if n was 1, it won't be here, right? But it will be if you add a pi over 2. I think we'll say n pi over 2 plus pi over 2, right? Okay. So that is what I was going to put in the little box over here. So as your parent functions. So all of that notation is going to be in that box right there. If you will finish up the back page for me before we start doing transformations, that would be most excellent.